Hello, and thank you for joining us for this session where we're going to be talking about our MSc in Advanced Manufacturing Systems. My name is Tina from the Brunel marketing team, and I'm joined today by the course director of Advanced Manufacturing Systems, who is QingPing Yang. Hi, QingPing.
Hi.
Thank you for joining us. Could you kick us off, please, with a brief bio of yourself and where you've studied, taught and researched?
Hello, my name is QingPing Yang, and currently I'm a reader in the Department of Mechanical and Aerospace Engineering, and I'm also leading two research groups at the university, and Quality Engineering and Smart Technology Research Group, as well as Robotics and Automation Group. My research interests include a number of topics: advanced sensors, IoT, instrumentation, quality engineering, and robotics, AI, and machine learning. And they are closely related to my education background in instrumentation and measurement, quality engineering, and robotics. Okay. And before I came to Brunel, I actually studied a master course program in robot control and intelligent control. And then I came to Brunel firstly as a visiting scholar, and later did my PhD here. That was about 30 years ago, nearly 30 years now. So I worked in China and the UK, and I've been teaching at Brunel the undergraduate courses and also the postgraduate courses for 3 decades. And I've been teaching in several countries, including UK, Greece, and South Africa.
Wow, thank you very much. And this particular MSc course, how long has it been running, and what's the main aim of the programme?
Okay, the MS course, or we call it the MS course, is Advanced Manufacturing System. Actually has a long history. It started in late 1980s, just before I joined the Brunel Universities. And over the years, it's been developed to reflect the changes in technology and also in industries. And the aim of the program is really to produce the leading engineers and researchers for advanced manufacturing systems. And currently, advanced manufacturing system is really the paradigm of Industry 4.0 and smart manufacturing.
I see, thanks. And there is some flexibility on the entry requirements. I know the standard entry requirement is a 2-2 in an engineering discipline as an undergrad, but sometimes work experience is also taken into account. Have you got any examples of that?
Yes, indeed. Our standard, the requirement is 2 or above in the science, engineering, technology, mathematical, and statistical disciplines. But if students have the qualification in other disciplines or lower degrees like third class honors, or indeed qualification like HND, HNC, if they have the good industrial experience and minimum 5 years relevant work experience, they can also be considered. And in fact, I had an example a couple of years ago. We had one applicant with the HND qualification, more than 5 years experience. He was really keen to join our course. We actually eventually offered him a place. He did really well in our course and graduated with distinction.
All right, yeah. Excellent. So those who come from a working background immediately before the course, what kind of backgrounds do they tend to come from?
Our students typically have a first degree or the background in the science engineering. This including mechanical engineering, electronics engineering, and computer science.
Right. And what kind of jobs have they been doing before they embark on the MSc?
If they have a work experience, they typically worked in manufacturing or mechanical engineering field.
I see. Okay, thanks. Now, it's worth saying that there are very often scholarships that our students can apply for, but it's very difficult to talk about them here because at the time of recording, they haven't yet been announced for the next academic year. So we would encourage all students, international and home students, to always check out these scholarship pages on our website. Right, now this isn't really the time and place to go through the great detail on all the modules, but it is important to run through the content of the course. We would always tell anyone viewing this to go to the website and look at the detailed explanations of each module. But QingPing, could you just sort of run through top level the content of the compulsory elements of the course?
Okay, yeah, our course, MS course, has 8 taught modules plus dissertations. So the 8 taught modules actually have 6 modules compulsory, and 2 are optional. So we typically have 2 terms, the term 1, term 2, or sometimes call it the autumn term and spring term. In autumn term, students are going to basically follow the logic of manufacturing, start with the computer-aided engineering is like design, and then the manufacturing systems and the economics. That covers basically various, the manufacturing processes and systems, and also there's a project management modules. So that's the term 1. So in the autumn term, the student will do 3 compulsory modules. That's we basically follow the logics of manufacturing as the design, manufacturing, and the simulation actually. So we have the first module is the computer-aided engineering, and then the other module is the second module is the manufacturing system and economics. Understand the broader, the context of manufacturing, and then the third one is the simulation and modeling. Okay. So this way basically is provide some kind of virtual manufacturing capabilities. Many students like that modules. So in term 2, the student will study the 3 additional compulsory modules, which is the, as I mentioned, in the technology, robotics and automations, and the sustainable manufacturing design. And also the 1 modules, advanced management systems and data analysis. Okay, so that covers the 6 compulsory modules. But additionally, they can select the 1 module in each term to complete the 8 total modules. In term 1, they can select either quality management and reliability or project management.
Right.
Okay. In term 2, they can select either logistics and global supply chain management or the design of I think it's called electronics systems.
Right.
Okay.
Right. And the dissertation is 60 credits, so that's a third of the whole qualification. Can you give us some examples of 1 or 2 different types of dissertation that recent students have submitted?
Okay, our dissertation actually covers a lot of topics. Essentially, it's related to our taught modules. As I mentioned, our taught modules covers the various aspects of the manufacturing design, manufacturing technology, inspection, metrology, and management side. So a number of topics, that are related to this. For example, I can give you 2 examples. 2 years ago, we had a topic which is related to one of our government-funded KTP project. The student actually worked on a dissertation topic on the acoustic panel fabric defect detection using machine learning and AI. The student actually was very interested in the project. He managed to develop the AI systems. We published 1 paper, and the student later on got a job offer from one of the top UK manufacturing company, Renishaw. Some of the audience probably
on the
knows.
basis of that dissertation?
Well, part of the dissertation. I think dissertation contribute to his job interview.
Yes.
Yeah.
Yes.
because he demonstrates that he can follow the latest technology and he can implement that in industry. The other example is actually more recent, in current year actually. Again, our project, the topic is related to a government-funded accelerated KTP program. And the student actually worked on a topic on the IoT and the big data analytics for sustainable manufacturing. Mm-hmm. And he actually worked on dissertation. At the same time, he worked part-time on that AKT project. The project completed so well, and now the company and together with the university are applying for further funding, government funding, to develop these solutions further.
Wow, excellent. Can you describe a typical week for one of your students in terms of how much teaching, how much lab time, private study, etc.?
Okay, yeah, this is related to actually the 8 module, module, the program structure. Yeah. So in each term, as I mentioned earlier, each student has to do 4 modules, but the timetable will allow them to choose 4 from 5. Typically, each day has a different modules. So the student will just do 4 modules or 4 days. And each module typically has a slot of 2 or 3 hours lectures. A few modules, they also have additionally some lab sessions, 2 to 3 hours. Any other times, our students basically just do their private study.
Private study, I see. Yeah. So the course is accredited by 2 institutions. Could you just run through what they are and let us know what the benefits are of the accreditation, particularly to both UK and international students?
Yes, of course. Yeah, our MS course has been accredited by the IMKE, which is the Institution of Mechanical Engineers, and IET, an Institution for Engineering and Technologies, for many years. As you know, these 2 institutions are internationally well recognized. Yeah. So they provide a lot of benefit for our students and our programs. So they provide basically a global kind of recognition, as well as the assurance of our program quality. Yeah. So our program follows the guidelines and the best practice of the institutions, and because of this, the student graduated from this program will have enhanced employability and the career progressions.
I see.
And particularly for international students, because you may move from UK to other countries. If your qualification is internationally recognized, that will give you basically the advantage.
Exactly, yes. Talking of careers, I was just coming on to my next question. Can you give some examples of recent graduates and the kind of careers that they've gone into?
Yes, okay. Yeah, manufacturing actually has been a very strong subject at the Brunel universities. For many years, 3 decades, since I joined the Brunel University, that's always the case. And our students have been widely recognized in industry in the UK and also internationally. And they typically can go to industries, find jobs, industries as a design engineer, manufacturing engineer, or managers. Yeah. Okay. Some of them also goes to universities as a researcher, doctoral researcher, or research assistant. Okay, I can 2 examples. One already mentioned earlier. One of the students 2 years ago went to work for Renishaw as a design engineer after his the AI project.
Is that a commercial organisation?
It's an industrial. Renishaw is one of the top UK manufacturing companies. It's really widely known in manufacturing field.
Right.
Okay, and the second example is actually, a couple of years ago, we had the MS student graduated from our program, and then she went back to China and worked there in industry. But then later on at Brunel, we had opportunities, a joint kind of research, PhD research, funded by TWI and Brunel.
Oh yeah.
And she applied, she got the offer. So now he's been working as a doctoral researcher in the company to develop a very interesting project to develop the robots for the non-destructive inspection or testing applications. And she's been doing so well, and she's going to graduate early next year, and is likely been offered a job in the company in TWI.
Right, excellent. That's in Cambridge, isn't it?
Yeah, Cambridge.
Yes,
yeah.
yes. Excellent. Well, thank you very much for that. We've covered today most of the areas that prospective students ask us about. But if there's still any questions that you have that we haven't covered today, please send us an email to the address that will appear on the screen, enquiries@brunel.ac.uk. And your query will be forwarded on straight away to Dr. Yang, who will write back to you. Okay, in the meantime, thanks very much for watching.
Thank you.